Good evening and welcome to this evening's webinar, Applications of Advanced Analytics to Decision Making. This webinar will be led by Pao Agulo. Before I pass on the headphones to Pao, I'd just like to give you a quick introduction. You may have already read about him in the marketing that we sent out when you registered. But I'd just like to say, Pao has been one of our senior associates with Informa. He is the Managing Director of Kernel Analytics, a consultancy specialized in applying quantitative methods to decision making. I'm going to pass this over to Pao now. I hope you enjoy the webinar. Thank you.
Thank you, Mega. Let me start the webinar by moving on to the objectives of the course, of the session that we'll be having today. The idea for the session is to provide an overview of advanced techniques of data analysis and how to use them in practice. So we'll review the several applications that are out there and the existing techniques so that you know how to use them in practice. So we will be reviewing the main existing techniques of statistical analysis and machine learning. We will be identifying to what kind of business problems they apply to and what kind of impact they can have from a business perspective. So whether we'll have more accurate forecasts or whether we'll be able to identify target audiences for marketing campaigns. Some preliminary considerations before we move into the different areas in which the statistical techniques can be applied to. First of all, let's state that data analysis intends to define and solve problems. So the first thing that we need to do is to identify what kind of problem, what kind of business question we're trying to address. And later on, we'll see what kind of data we need and what kind of statistical technique can help us provide a good answer to that business question. The reason why analytics and big data is a growing practice and a growing business worldwide is because data is gathered more and more in recent decades or recent years. We are gathering data like we never did before. This is due to several processes. One is that we are in the past recent years or decades, our companies and our public administration have been digitalizing processes, both internal processes within the company or external, how we interact with our customers. So customers interact digitally with the companies that they buy products from. So they buy online or they buy through a web app, a mobile phone app. So all this allows us to track the interactions that customers have with companies. And this is the raw data that we use for many of the analysis that we'll be considering today. In addition to the process digitalization, the cost to store all this data has fallen dramatically and keeps falling every year. As a result, it is more feasible for organizations to store this data and then later on analyze it. Also, the processing power has increased very significantly and still continues to do so. That means that we can analyze larger and larger volumes of data. The combination of the two is what makes this field so relevant. On top of all this, there is more availability of public and semi-public data. Namely, public administrations are providing anonymized data about their country, about the population, about the companies that they have. So this public data can be combined with internal data to provide more holistic, comprehensive analysis. One last remark. So from small data to big data. Initially, statistics was defined to draw inference from small samples. So given that gathering data was so costly, statistics was all about how with a small sample I can draw inference to the whole population. Now, conversely, we are more concerned about how to draw conclusions from large amounts of data. So the recent techniques that have been evolving in the last years, such as machine learning, they are more focused on how to deal with large volumes of data and how to extract knowledge from such huge amounts of data. The concepts that we'll be discussing in this session are general, and the techniques as well, and they take different forms depending on the industries or the kind of companies that they apply to. But I'll try to refer to concepts that are as general as possible. First of all, let me state that data analysis can be used for both tactical and strategic decision making. And sometimes we use basic statistics, and sometimes we use more advanced statistics. Most data that people use today is structured data, and this gives place to data mining. But the volumes of data that are stored these days very often includes text. This is unstructured data with all its complications and complexities. Text mining can also be used for both tactical and strategic decision making, and it can be used to infer like the sentiments that customers have on their companies. Okay, in terms of tactical decision making, when we try to make a decision that is tactical, this means that very often that we try to optimize and very often automate a decision where there is an operational and technological capability to implement it with precision. So this is a question, a business question that we need to be answering over time continuously. And this could be selecting a group of customers for a campaign, and also it can be forecasting what is the demand for a product in a given store and a given day. Therefore, this is very closely linked to daily operations, and typically are decisions that need to be made in the short term and in the midterm. Therefore, that it makes sense to try to automate and optimize it. At the same time, when we analyze tactical decision making, typically, not always, but typically it involves predictive modeling to make the most of the granularity of the data and to try to get as much precision as possible. The degree of sophistication is variable depending on the data availability and the decision at stake. So there is some sort of cost-benefit analysis. If there is a high benefit of developing more sophisticated predictive models, then it will be worth the investment. But if the return is low, then we might get by with a more simpler approach. Any data analysis, however sophisticated, is a mix of analytics and business. Typically, when we try to automate decision-making that might be even daily, this mix is tilted towards analytics, because any additional percentage point of precision, of accuracy that you put in the models has a payoff that stretches on into the future. This often derives in systems that have an analytics core inside, with more or less discretionary action from the business user, depending on the mix of business and analytics, and depending on the vocation of long-term solution that the system has. So and it depends on how well an algorithm competes with a human. So sometimes it's fully automated without human interaction, and sometimes it is a decision support system that helps humans, so the business users, make decisions, but not fully automated. Conversely, when we try to make strategic decisions, the goal is to answer a big question, a very relevant question for the business at one point in time. And this could be high level at the CEO level, or it could be at a department level. But it is not likely that we will be having to be making that decision later on in the future. For that, there is typically no need to automate the results. So sometimes the analysis that has been conducted to make the strategy decision ends up in periodical reporting, but rarely a predictive model. In this case, in contrast with tactical decision making, the mix of analytics and business is tilted towards business. Most likely, or most of the times, because there are quantitative and qualitative aspects to it. So the results need to be interpreted in a certain business context. So the decision will be a result of the two. As in tactical decision making, the degree of sophistication is variable depending on the data available and the decision at stake. The end results here tends to be a report, a presentation, or a spreadsheet. And these will often need inputs from other stakeholders in the decision process. So here it's a plus to have some simplicity so that it can be more transparent and more simple so that everybody can understand what the drivers of the decision are and therefore validate the decision. Most of you will be familiar with basic data analysis. These include percentages, and in percentages we can have conversion rates, churn rates, cross-sell rates, and this reflects the efficiency or the efficacy that we have to attain certain business goals. We also use ratios, for instance, the average revenue per user, or ARPU, or the average ticket for a retailer, and so on. These are very helpful for profitability purposes, to know how much of my revenues come from what kind of customers. There are also some time-oriented series. So this is typically to allow us to evaluate the trends of some of our internal KPIs, like sales, whether there are some seasonality to it or occasional spikes. This is typically to know what time evolution these variables have over time. And frequency tables allow us to characterize and explore category data, and sometimes even it helps us to establish causality. Now, in terms of advanced predictive analysis, there are certain techniques that you need to be aware of. I will mention them briefly, and later on I'll be seeing what kind of business problems they apply to. Regression tries to explain one variable as a combination of many other variables. The variable that we are trying to explain can be a continuous variable, count data, or also a binary outcome. And depending on this, we will be using different shapes or different forms of regression. So logistic regression, for instance, tries to predict binary outcomes. So it will tell us what are the drivers that explain somebody buying a product or not buying a product, canceling a service or not canceling a service. And the regression will tell us what factors need to be included and what factors matter and how much each one of them matters, so that we can get some insight, some business insight on how important each factor is, but it also allows us later on to score individual customers based on those variables. Decision trees. And decision trees try to discriminate within a sample of users that we're analyzing. We try to analyze differences. What are the factors that separate, that discriminate the most between 2, 3, or more groups, depending on what variables. So here we try to get customers that have a very high propensity to churn or to buy a product, conversely those that can exhibit a very low propensity. Decision trees are very good at allowing for nonlinear effects compared to regression. Clustering techniques like k-means are typically used to group customers or group units of analysis. So here we're not trying to predict one variable as we did with regression and decision trees. Here we're simply trying to group together customers that are similar and separate in different groups or different clusters customers that are very different from one another. It's typically used for customer segmentation. So we try to understand what our customer base looks like and then get a profile for each one of the segments. Time series, here we try to predict the future values of a certain variable, for instance, sales. So we try to forecast how many products we're going to be selling at each point of sale or each country over time. So the most important, the most relevant variable for time series is past sales, so the past behavior of the same variable with some lags. But it can also include external variables. So if we're trying to predict newspaper sales, it can include the promotions that we're doing or the news that are available in the newspaper that particular day or the point of sales that are open nearby, etc. Machine learning techniques have emerged in recent years to deal with large amounts of data, and random forests are built using decision trees, but you apply decision trees to a large number of samples within the universe of analysis, and then it groups these different decision trees by averaging out the coefficients that we find in the data, in the estimation, and it builds more stable, more robust indicators, richer models, and it allows to look at nonlinearities quite in a quite sophisticated way. The only requirement for machine learning is that we need large amounts of data. That's why they've become so relevant in recent years. Finally, neural networks have been tried to mimic the way the human brain works. So between the input variables and the output variables that we're trying to predict, there is a middle layer that allows for a wide complexity of interactions between these inputs and these outputs, which is more or less how our brain works. Neural networks are also very demanding in terms of processing power and data. Now, when we use advanced statistics for decision making, it is important that we define the problem before we look at the data. So don't let the data define the problem for you. First of all, make sure that you have understood what the business question is, and then once that is clear, identify the data that you need to solve that problem. Very often you will not have all the data you need. But at least you will be able to say what data you will need in the future, so that the data will start being gathered, and then maybe you can start working with the data that you have available. So this is an important first step. Secondly, devote enough time to define the variable that you're trying to predict. Very often, big mistakes are made at this step for not thinking thoroughly what is the variable that we're trying to predict. So for instance, in banking, it is very different trying to predict who has a product versus who hires a product, especially if you look at long-term products like a mortgage or a credit card. If you look at who has a mortgage, those will be people who are in their 50s. But if you're seeing who's hiring a mortgage, you will get people who are more in their 20s and 30s. So it's very important that you define well the product. Or even if you're thinking about launching marketing campaigns, it will be who accepts your offer versus who does not accept your offer. So all this is important, that you understand the data well enough to identify the valid events so that you construct a good data set from which you can conduct your analysis. Another important factor, once one has a lot of data, it is tempting to try to correlate every single variable with a variable that you're trying to analyze. This might lead to spurious effects that are not desirable. And they are not desirable because they might appear at certain points in time, but do not hold over time. So make sure that you only include variables that make business sense or make economic sense to be included. So if you cannot explain from a theoretical point of view why a factor is driving your sales or driving your cross-sell actions, you shouldn't be putting it into your analysis. It is also important to understand the limitations of the data sample that you're working with. So very often we only have the chance to work with data that has been generated in a boom or in a recession, in an expansion market or in a mature market. So it is very difficult, or it might lead to the wrong results if you try to use a model that has been developed with data developed in a boom to apply it in a recession where the customer behavior will be different. So beware of structural changes and where is your data coming from. Finally, stay aware of the advantages and the limitations. Math and statistics is not magic, but these are extremely powerful tools that we can use to improve decision making. In terms of methodology, as I said, first we need to define what the problem is. So in that case, it can be how many newspapers I'm going to be selling, or how many products, or who is going to cancel, who's going to churn from my customer base. Once this is defined, we can identify the data that we need and go and get it. Then we need to clean the data. Cleaning the data involves, very often we have missing data, or very often we identify that there are inconsistencies in the data, or we have duplicates in customers. So this is something that we need to be very aware of before we start analyzing, and we need to devote enough time to clean the data so that the results are robust. Then we need to prepare the data for the analysis, for the execution of the predictive modeling. Preparation involves transforming from the original data into variables that can feed into the model. So for instance, if we want to build a variable of what is the tenure of a customer within a customer base, then we need to go and get the activation date and from there see for how long this customer has been around. And so most variables need to be constructed from the original data. Then we conduct the analysis or the predictive modeling. So we apply all the former techniques to trying to better understand the problem. So what are the drivers? What are the explanatory and predictive factors that affect the behavior that we're analyzing? Then we evaluate how well the analysis performs. So how much accuracy do we get from our model? And because this will be important also when we link it to the next step, which is the business application. So if we have extremely accurate results, then we can automate the business decision more. If it's less accurate, then we might want to involve a business user to validate the results and maybe to bring in some expert knowledge as well. Finally, we need to present the results, typically, oftentimes to non-expert in statistics audience. So we need to present it in a careful and simplified way so that everything is understood. And installation, not always, but if we're trying to automate and optimize a tactical decision making, the predictive model can turn into an algorithm that is installed in the systems so that it continuously provides in an automatic fashion the decision to the users. There are several applications for advanced statistical analysis. So one is marketing and customer intelligence, risk management, supply chain and operations, fraud detection, revenue management, and many others. So we'll be seeing a bit of these, which are the main ones that are being used these days in many different industries, both tactical and strategic, combining both data mining and text mining, basic and advanced. And these apply, as I said, to many different industries. The kind of industries that they apply are the ones typically in which we can identify customers and we can track their behavior over time, and that we have the technological and the business possibility to address them in a customized way, one-on-one, so that we can personalize the customer touch points that we keep with them, making sure that we increase the relevance of the interactions that we have with them. And as a result, this can be transformed into higher conversion rates and more loyal, durable, profitable relationships that we keep with the customers. So marketing and customer intelligence. Here we're generally trying to answer the question, what should be done with each customer at each point in time, given all the different alternative treatments or actions, marketing actions that I could address to each individual customer. So this, of course, takes different forms in different industries. In banking, we'll be offering banking products, and in telecommunications, we'll be offering data and voice and different rate plans and promotions. Or in retail, we might be doing personalized recommendation of different products. We might be recommending books or movies. Typically, we try to identify the different opportunities and risks individually. So what are the size of the opportunities that we have with each customer so that we can address them, or what risks are around and how we can mitigate these risks. So these would be cross-sell campaigns, upsell campaigns, customized recommendations, so one-on-one product recommendation, or try to estimate how satisfied the customer is. Or in terms of risks, it could be churn, so the risk of the cancellation, or a downward migration in terms of rate plans. In all these cases, first we try to assess the probability of the event of the cross-sell or the churn, and then also the benefit or loss in case that that event takes place. This is because we combine the two so that we can have a common metric for all these opportunities and risk, which is expected benefit or expected loss. Once we have identified with the propensity models all the opportunities and risks, then we need to see how we address these opportunities profitably. So this means if I launch a direct marketing campaign or if I customize the products that I show, what are the results that I'm likely to get? So this can be incurring a cost or without incurring a cost, for instance, through email. So determining the kind of strategy that I can use and the benefits. So typically this brings in a different dimension, which is what is the conversion rate that I get with these campaigns, and then I can build a cost-benefit analysis. So the analytics part is conversion rates, the cost-benefit analysis is more of a financial decision, and we combine the two to optimize profitability. At the same time, the one possible extension of this is mixing massive and direct marketing. So in massive marketing, typically we try to optimize marketing mix. So this tries to address the question of how should I be spending my marketing budget? So where should I be putting my advertisement money on TVs, radios, online, etc., or newspapers? So far for marketing. Let's move to risk management. In risk management, we want to quantify individual and aggregate risks. Credit risk is where analytics is applied most of the time, but also other risks such as operational risk. Here, as in marketing, there is a split between the likelihood of the occurrence of the event and the severity of the consequences. So likelihood would be what is the likelihood that somebody does not pay back a loan, and the severity would be what is the money that he will not pay back, how much money that is, so that we can estimate the overall expected loss. And based on this, make decisions on granting loans and under what conditions, so that the price and the conditions match the risk incurred. This gives place to credit risk scoring. So this is used to automate and standardize the decisions to grant loans, mortgages, credit cards, etc. for consumers, and renting cars, leasing, and so on for companies. This is done statically and dynamically with multiple data models based on market and the legal frame. And again, it's a mix of analytics and expert knowledge depending on the size or the type. So more analytics and more automation take place on smaller transactions. And the bigger the loan and the more heterogeneous the universe is, such as with companies, the more there needs to be human validation and human intervention. Operational risk tries to address what is the probability that some operational process will fail. Here there is high heterogeneity of cases, so there's always a mix of qualitative and quantitative analysis to address these kind of risks. The more quantitative type tends to be predictive maintenance. So we try to predict what is the likelihood that a machine will stop working based on the data that we get from different sensors that the machine is continuously sending. So this can be applied to engines in cars, but it could also apply to printers in offices or bank offices. Of course, there are many other risks like asset and liability management risk, portfolio risk, aggregate risk of the bank, and this involves both statistics and regulation, but this we're not going into this detail at this moment. It's just good for you to know that it exists. In terms of supply chain, the most basic and typical question that we get here is how much am I going to sell for each product every day and each point of sale? And of course, it could be groups of products for a longer period of time and for regions or groups of point of sale. But the most granular prediction would be each product, each day, each point of sale, and of course, with a certain amount of time in advance. And this, of course, is used for purposes of logistics and production. so that we know how much to produce and where we should be delivering the products to, so that we do not have excessive stocks and we don't run out of products in our stores. Of course, we need to include past sales data, but at the same time we need to integrate external variables such as promotions or seasonal effects or competitive effects, so what our competitors are doing. Here, in order to know how sophisticated your solution needs to be or your model, we need to understand what is the value of a forecast. So there are certain costs and benefits with respect to alternative forecasting methods, from the most basic ones with lower accuracy to the more sophisticated ones with higher accuracy. And based on this, we will define whether we need a reactive or a proactive system. So often we can act reactively. So whenever a product is sold, the next day I can bring in some extra products. But sometimes we don't have that occasion and we need to be proactive. A good example of this is newspapers. So we need to know in advance how many newspapers we're going to be selling because it's the most perishable good. Therefore, the next day it's too late to get it right and we only have one chance to deliver the product to each point of sale. Also, we need to take into account the safety stocks. So we estimate the volatility of the forecasts. So once we know how much we're going to sell, we need to see how volatile, what is the variation around that number. And we apply a cost-benefit analysis to determine the optimal amount that should be placed at each point in sale. And this way, we balance the stock out and the excessive stock costs. Other applications are pre-season. So everything I've described so far is what is called in-season forecasting. Other applications that you might want to know about are pre-season forecasts. So this is used to improve purchases. Stock redistribution across stores. This takes place once all the stock has been distributed and we see excessive and missing stocks in some stores so that we can redistribute across them. Or decisions on optimal assortment of products. So how many different coats I should have in a fashion retailer, for instance. Fraud detection. Fraud detection tries to address the question on how likely it is that this transaction that takes place now or this use in this application is legitimate. Namely, what is the probability that somebody is trying to use my credit card to do a fraud transaction. So credit card is both online and offline is the most obvious case, but there are other markets that attract fraud as well. So pay-per-view TV, football is another classic. In telecommunications, there's also fraud. Or in classified ads, there are some fake ads. Of course, the severity or the consequences of all these things, both in economic and legal terms, are different, but this is all examples of fraud. Here, when we try to use this decision, we need to be aware of the value of false positives. So if I accuse somebody of being conducting a fraud transaction, I need to be aware that statistics is never a deterministic issue. So there's always probabilities involved. So if myself, I live in Barcelona, so if somebody with my credit cards buys a fridge or a kitchen in Moscow, then it will be likely that there will be a high likelihood that that transaction is being fraudulent. However, so we need to be aware the embarrassment if the action is severe. So very often, if we're not 100% sure or with a high degree of significancy, we might want to do checks instead of not allowing the transaction to take place. In fraud, there is always a competition between technology and analytics. Yeah, analytics by definition is never completely sure about everything. We have probabilities that something is a fraud. The thing is that fraud is changing by definition over time because companies are trying to protect their business from fraudsters, and fraudsters try to overcome it. So this is a race that they keep having. So it is difficult to find stable patterns over time. It's a continuous race between one and the other. So probably most likely technology is the best answer in the long term, but in the short term analytics, because now the technology, they make it more difficult to clone credit cards. So this way we avoid or minimize false positives. But in the short term, analytics for a given technology can identify patterns that are too strange to be true and therefore can help avoid or minimize fraud. In terms of revenue management, the question that we're trying to address is at what price a service should be sold or purchased to maximize revenue. This applies to what is called club goods, so excludable, non-rivalrous goods. This is hotels, airlines, entertainment. So what all these businesses have in common is that they have a fixed amount of rooms, seats in the hotel, seats in the airplane, or seats in the football stadium. And once that day passes by, we no longer can sell that available capacity. So we need to know what is the price in which we can fill the hotel, the plane, or the stadium at the best possible price. So that is the question that we're trying to and that's why we pay different prices, even being in the same plane or the same hotel, depending on how far in advance we've made the booking. So this is typically an extension of demand forecasting. So it's demand forecasting models in which there's a price or a discount as a variable inside. So anticipating future demand, we are considering the different alternatives for products. So what other flights compete with mine, or what other flights with my own company in different days there are. So we anticipate the future demand. We see how it depends on price. And based on this, we try to fill the capacity at the maximizing revenue. Of course, once we do this, we need to be aware of that people always try to minimize the price that they pay. So we need to be limiting the opportunistic behavior, making it non-predictable. So we cannot be following the same strategy over and over. Namely, we need to make that the lowest possible price to buy the ticket is precisely 15 days before the flight, because then most people will wait until that day. So it needs to be non-predictable from the customer perspective. This same logic can be applied to minimization of costs when purchasing raw materials, when it is best to buy. And finally, we'll be looking at other applications. So point of sale optimization is another growing practice. And here we look geolocated data with coordinates to analyze, for instance, the performance of our current point of sales. So we look at our point of sales, we look at where they are located, we determine what amounts and what type of population live next to each point of sale, and then we try to understand how this relates to the profitability of current point of sales. And once this has been established, we can determine where to open new ones where we don't have coverage today based on the expected demand and the competitive environment that we have learned with the current point of sale. So this is to optimize the capillarity of the distribution network. Product analysis. Product analysis, product clusters are typically based on attributes. So we are analyzing the behavior of shirts or trousers or jackets. But there are some recent developments in which that get more creative. So for instance, we cluster products based on the characteristics, or even better, based on who buys them. So you can identify products in non-obvious ways. So if a certain amount of products are bought by the same kind of customers, it means that they have something in common that might be not apparent or might not exist in the characteristics of the product. So it could be a certain flair or a certain style that cannot be captured by the simple observable characteristics of the products. So it can bring in new dimensions that the company, a fashion company, is not aware of. It also there is also some room for improvement in optimal assortment and the impact on sales. So how many different coats should I have to maximize my sales on coats? At some point, any incremental coat will not add on to the overall coats sales. So this is the end of the presentation. We've seen what kind of techniques there are available. We've seen how to use them in practice, and then we have explored the different areas of business in which they can be applied to and with what added value from a business point of view. It's been a pleasure being here with you tonight, and hoping to speak to you soon in the future. Thank you very much.